Hello, my name is Reed, and I'm here to give a quick demo on our embedded DisplayPort, panel replay, and ALPM functions. Here on the DPRX page, we can see our embedded DisplayPort bit rates. Currently, we only support the given range. However, eDP bit rates are incremented in 200 kilobyte steps. Here, we have the embedded DisplayPort aux preamble. This is a function that shortens the preamble between messages. In standard DisplayPort, the aux preamble is 30 zeros long. However, in embedded DisplayPort, the aux preamble is 24 zeros long. We can see this by heading to the event log, turning on aux bitwise, link training, and we can see here that our preamble is 24 zeros long. Back on our DPRX page, we can see our scrambler seed. This is a function that scrambles and unscrambles the data in between the two boxes. Here we have ours set to the standard DP scrambler seed, FFFF. Here we also have the option to set it to the eDP alternate scrambler seed. If we set it to this seed, we can see that our frame rate drops to 0. This is because our TX and RX are using different scrambler seeds. In the DPTX page, if we set our scrambler seed to the same one, we can see that our frame rate goes back up to 60. We have a good video stream. Now we're on the ALPM page. Here we can see our link status, link control, power off entering and exiting, as well as our errors. Here we can enable ALPM. We have our manual controls and automatic. Here we have our power off exiting. Auxless uses sequences in the main link to tell the device when to wake up. If you use aux wake, the device will use the aux channel to signal the device to wake up. Here, over on the link analyzer, we can download the main link and show you the vertical blanking. Now that we've downloaded the main link using the link analyzer, we can see our ML5 sleep commands. Back on the ALPM page, we can swap our power off exiting to aux wake. Now, in the event log, we can switch on the aux bitwise start, and we can see our eDP 5 wake messages. Now we're on to the panel replay page. Here we can see our current pattern capabilities, configuration, our command window, our status, and history. Here in our configuration, we can see our different modes. We have panel replay, PSR1, and PSR2. Standard DisplayPort only supports panel replay. However, embedded DisplayPort also supports PSR1 and PSR2. Here we can see our commands. We have disable, inactive, active, full screen update, and selective update. Full screen update will apply to the entire screen. Selective update allows you to enter in regions here that allow you to specify the region in which the panel replay is acting. If we go ahead and set the panel replay to inactive, we can go to our event log, secondary data packets, and turn on only VSC7. Here, in our secondary data packets, we can see our panel replay state, 0, inactive. Heading back over to our panel replay page, we can toggle it to active. Heading back over to the event log, start, stop. Here we can see that our panel replay state is active.